Now, if I want to add complex numbers, phasor is going to be, again, dealing with complex number. Soon enough, you're going to see me. One of the nice thing about circuits, too, you can take a circuit, like an RLC circuit. Instead of solving that in time domain, what I tell people we're going to do to it, we're going to take the circuit from time domain, we're going to transform that to complex, or phasor, which is complex. So we're going to transform it. Then we're going to solve it in phasor, which will be much, much easier and quicker. Then after we finish with that, we're going to change it back to time domain. That's really what the goal of this technique here. It is much easier to solve the problem in phasor, RLC circuit in phasor, than in time domain. But you can only use this method if your source either sine or cosine. If your source is not a sine or a cosine, this method doesn't work. So the plan is, how do we go from time domain, change it to phasor? How do we go from solve it in phasor, after that change it back to time domain? Well, before I talk about all these pieces, how do you go from time to phasor, solve it in phasor, then change it back to time domain, let's talk about phasor, complex numbers, complex values there. A complex number usually has a real portion and imaginary portion. So the complex number a, for example, it might be 3 plus 4i. We use I or j, which is the square root of minus 1. You might see us actually in circuits use j instead of I. Why? Because we use I for current. So in circuits, a lot of times you'll see that written as 3 plus 4j instead of I, where j is the square root of minus 1. That's a complex number. If you graph a complex number, you know it has a real portion and imaginary portion. The x-axis represent the real portion, and this represents the imaginary, the complex. So you got to travel 3 units in the real portion, right here, and 4 up. So that's what 3 plus 4j is. It's a complex number that has a real portion and imaginary portion. And the question is, how do we add, subtract, divide, and multiply complex numbers? Add, divide, subtract, multiply. So let's see. If I take these two complex numbers, a equals 5 minus 2i, or 2j, and b equals 7 plus 4j, and I want to add them. What is a plus b? That would be 5 minus 2j, add to it what? 7 plus 4j. Pretend j was x, and think about algebra. If j is x, and this is algebra, how would you add them? Collect like terms, right? So we take the 5 and the 7, we add them together. What's 5 plus 7? 12. And we take the x's and combine them. What's negative 2j plus 4j? 2j. And if I go to my calculator now, and I do that on mine, let me put my calculator in rectangular mode just to show you it's working. Polar rectangular mode, because that's called rectangular mode. So here we go. Let me ask my calculator to do the work for me. 5, comma, negative 2, that's 5 minus 2j. I want to add to that 7 plus, or not plus, I can't do plus on this, you do comma, 4. And if I hit enter, it should give me 12 comma 2. There we go, 12 comma 2. 12 plus J2. The TI-84 does them a little bit different. If I want to do A minus B, that would be what? 5 minus 2J. And I want to subtract from it 7 minus 4J.
It'd be 7 plus 4J.
Oh, yep, plus, yep. So this will be what? 5 minus 2J. This becomes negative 7 minus 4J. What's 5 minus 7? Negative 2, and that's what? Negative 6J. Again, 5 comma 2, or negative 2, minus 7 comma 4. Negative 2 comma negative 6. Addition, subtraction, straightforward. We're a little bit messy there. Well, not messy, but more work is when you have multiplication and division. What is A times B? Again, that's 5 minus 2J times what? 7 plus 4J. Again, pretend that's X. J is X. And you want to multiply these two. How would you multiply them out? FOIL them. What's 5 times 7? 35. Plus 5 times 4J, which is what? 20J. Minus what? 14J. And minus what? 2 times 4? 8J squared. Remember, J is what? J is the square root of minus 1. What do you think J squared is then? How about negative 1? Squared, right? So since J squared is minus 1, this becomes what? 35 plus 20J minus 14J, and this becomes plus 8. Collect like terms. 35 and 8. 43 plus 6J, right? Let's see if that's what we have. Parentheses, 5 minus 2. I'm going to multiply it by 7 plus 4. It's 43 comma 6. 43 plus 6J. And that's what we got. How about dividing them? What's A divided by B? Five minus 2J over 7 plus 4J. Well, dividing is a little bit different. Why? Because if you think about that, what you have is 5 minus 2 the square root of minus 1, that's what J is, over 7 plus 4 the square root of minus 1. And if you were doing this in math and algebra, the only way to divide them is how? Begins with the letter R. Not reciprocal. Rationalize. You got to rationalize the denominator. And how would you rationalize the denominator? Normally, you take this and you multiply it by, you switch that sign. That's what we do in math. We multiply by almost the same thing, except we switch the sign. So when you have division here, I'm going to do this without the square root. We're going to multiply by what we call the conjugate. And my conjugate here, it's 4 minus, notice we're changing the sign. It will be 7 minus 4j Remember the conjugate? It's called the complex conjugate here because these are complex numbers.
You don't put a negative sign in front of the sign?
No, you switch only that sign, Nick, between them, between the real and imaginary. And now we're going to do the foreign method for each one. So 5 minus 2j. And you'll see actually why we're switching the sign in a second. And now let's FOIL them. And do the same thing. If you FOIL each one, 5 times 7 is what? 35. Minus 20j minus 14j plus 8j squared. That's the top. The bottom, 7 times 7 is what? 49 minus 28j plus 28j minus 16j squared. Here's why we switch the sign. Notice what happens here. They cancel each other out. This becomes a negative 8. J squared is minus 1. What's 35 minus 8? (35 minus 8) is that 27? Minus 20 and 14 is what? 34j. What's 49? This becomes a plus 16. J squared is minus 1. What's 49 plus 16? Is it 65? So when you write that as a complex number, 27 over 65 minus 34 over 65 j. And if you want to divide them, change that to a decimal number. 27 divided by 65 is, I'll just carry a few decimal places, 0.4154. 34 divided by 65, 0.5231j. So when you divide them, it's really not a pretty way of doing it. Bless you. Thank goodness the calculator actually does that for us. Let's see if my calculator gives me the same answer. Here we go. 5 comma negative 2 divided by 7 comma 4. 0.4154. Is that what we got? Notice 0.4154 minus, can you see it? 0.5231j. Can you see that? I just move this to the right to get the second value. Looks dark a little bit there. Yep. The first value, 0.41538, and the second value is negative 0.5231 j. But the calculator does all these steps for me. You really could not add, if you want to multiply and divide, you want to be in polar. If you want to add and subtract, you want to be in rectangular. But before we do that, how do we go from rectangular to polar and polar to rectangular? This is physics, this is vectors. If I have a vector that's 4 plus 3j, and I want to change it to polar. What that means, You get 4 units in the real direction, that's 4 here, and you get 3 units up. And what I'm looking for, what is this value, r, and what's this angle theta? So this here is called rectangular mode. How would I change it to a polar? I want to take this and convert that to polar. I want to know what r, and I need to know what theta is. Can you tell me what that is? That's what polar is. Well, think of math, think of physics. How do you find what r is? Yep, what r first? Yep, r is the square root of the real portion squared, which is the 4, plus the imaginary portion squared. My real portion here is 4 squared. The imaginary is 3, not the j, without the j. 16 plus 9 square root 25, which is what? 5. And if you're doing it by hand yourself, how do you find theta? Theta is the inverse tangent of the imaginary over the real. Theta is the inverse tangent. The imaginary is what? 3. The real is 4. So here we go. Second tangent on my calculator. Where is it? Second tan. Parentheses 3 divided by 4. 36.86 or 36.9 degrees. If you're doing it by hand, you have to be careful, because if you're on the second or third quadrant, the calculator always gives you the angle off. So you have to add 180 degrees, unless you're using the built-in function. If you're just doing the inverse tangent, notice if I have something in this quadrant, the machine doesn't know who's negative. Watch this. I'll do one just to show you. If I use the built-in function, I'm good. I don't have to touch it. Notice if I just take this calculator and I go, you know what? Let me change the mode on that to polar. And if I switch to polar, I'm good. The machine knows which quadrant I'm in. I don't have to adjust it. If I just write the values, which is 4 plus 3j, 4 comma 3, and I hit enter, it should give me 5 angle 37 degrees, whatever. 5 angle 36.9 degrees. It knows. It does it automatically. And if I'm in this quadrant or that quadrant, it knows too. But if you weren't using the built-in function, you have to pay attention to it, because if you are, let's say in this quadrant, and you have obviously a negative 4, because x is negative now, and this one is 3. So A equals negative 4 plus 3j. And I want to change that to polar. What is r? And what's theta? Theta is always measured from, this is your reference. It's always measured from the positive x-axis. So to get r, it is the square root of negative 4 squared plus 3 squared. That's the square root 25, which is what? And to get theta, it's the inverse tangent of the imaginary, which is 3, over the real, which is negative 4. Here's what's going to happen. The calculator is going to divide these two numbers. It's going to be a negative number, but it doesn't know where the negative is coming from. It thinks it's coming from this quadrant, and will give you an angle in that quadrant. We know that's wrong. So let's try that. Inverse tangent, parentheses, 3 divided by -4. It's going to give me an answer in this quadrant, quadrant 4, negative something. Notice it says negative 36.9 degrees. We know that's not right. So how do you get the right angle? You need to add 180. So if you add 180, it says what? The angle is 143.13. So if you are in second or third quadrant, add what? 180 degrees to your answer. Unless you're using the built-in function. If you are using the built-in function, the machine knows what that is and will give you the correct answer. Watch, I'm using my built-in function. I go, can you tell me, convert -4, 3 to polar? I'm going to use the built-in function. It will give me the correct answer. 5 angle 143.13. But if you're not using the built-in function, you're just doing it yourself like this on your calculator, then you have to add that 180 degrees. So that's how we go from rectangular to polar, and you can go from polar to rectangular. How do we go from polar to rectangular? Polar, you normally have the angle given like this. You go, we have a vector that's 10 units long with angle, 36 degrees. So I have 10 angle 36 degrees, and I want to change that to rectangular. I want to find what the real portion is, what this side is, and what this side is. I call this x and y. So I want to change it to x plus jy. I want to know what the real portion is, what the imaginary portion is. Again, this is physics. To get x, you do what? R cosine theta. My R here is what? 10 cosine 36 degrees. .1, and to get y is going to be what? R sine theta, 10 sine the 36, 5.88 or 5.9. So we can say 10 angle 36, if you want to change it to rectangular, is approximately 8.1 plus j 5.9 or 5.88. It doesn't really matter if you write j first or last. Now if I take my calculator, switch it to polar mode or rectangular mode, here we go, let's see if it works. Mode, and I want to be in rectangular. And I write this. We said 10 angle 36. Now let's hit enter. 8.09 to the 8.1. Can you see that, comma? 5.88 roughly. It does that for us. Normally, if you're doing it by hand, you can't add in polar. You can't subtract in polar. So if you have values in polar and you want to add them, you really can't add them. So if I have 10 angle 40 and I want to add to it 7 angle 29, I can't. I got to convert them to rectangular. So I got to take this, go 10 cosine of 40 plus j 10 sine of 40, add to it, seven cosine 29 plus j 7 sine of 29, and my answer is going to be in what? Rectangular. Then I got to convert that to polar. Ten cosine 40 is 7.66 plus j 10 sine 40 6.43 7 cosine 29 6.12 7 sine 29 should be around 3.5 3.39 9.82, that's the j portion of it, and the other one 7.66 plus 6.12 13.78. Notice that's my answer in rectangular. I don't want it in rectangular, I want it in polar. Now to convert that to polar, r is going to be the square root 3.78 squared plus 9.82 squared and that's 16.92. And to get theta is the inverse tangent. I happen to be in the first quadrant. Notice both are positive. See them? Because they're both positive, you are in the first quadrant. So I don't have to make any adjustment. Inverse tangent of the imaginary, which is 9.82, over the real, which is 13.78. Second tangent, 9.82 divided by 13.78, and that's 35.47. I'll go 0.5. So when you add them, what's 10 angle 40 plus 7 angle 29 equal to? 16.92 angle 35.5. That's a full page. But again, if you have one of those calculators, you go, okay, I don't have to do all this. 10 angle 40. After today, I'm not doing this by hand. I can tell you that 7 angle 29. I type them and go enter. 16.92. Is that what we got? And what's the angle? 35.47, 35.5.
And you're in polar, right? Okay.
That's in rectangle. You want polar? I could just switch the mode.
Oh, you want it right. Okay.
I'll go, you want rectangular? Switch the mode. Get out of this and hit enter again. It converts that. Notice 13.78. Is that what we got? 13.78. And the imaginary portion is what? 9.82. So much easier. What we're going to do in next class is take a circuit in time domain, show you how we change it to phasor, solve it in phasor, now you know what complex numbers are, and take the answer back to time domain. That's what phasor method is. So that's actually next class, not today.